Hello and welcome to Q Academy free course series. In this course we will learn about blockchain technology. This technology has gained immense popularity and is poised to disrupt various industries. This introductory course is designed to provide you with a comprehensive understanding of blockchain technology, its fundamental concepts, and its potential applications. Whether you're a beginner with no prior knowledge or a professional looking to enhance your expertise, this course will equip you with the foundational knowledge necessary to navigate the world of blockchain. The term blockchain technology is often used interchangeably to refer to various concepts. It can pertain to Bitcoin, cryptocurrencies, digital tokens, Ethereum blockchain, or smart contracts. Unfortunately, this widespread use of the term blockchain has led to confusion among many individuals. However, all these usages share a common thread: the underlying technology known as distributed ledger technology. In distributed ledger technology, transactions are duplicated and stored across individual computers on the network, as opposed to being centralized on a single server. Despite the rapid growth of blockchain technology, it has remained relatively obscure to many developers and technology enthusiasts. While numerous blogs and dedicated websites attempt to explain this technology and its associated developments, there appears to be a shortage of a comprehensive guide that clarifies, compares, and contrasts the overlapping terms and terminologies related to blockchain. In response to this need, Q Academy has taken the initiative to create a comprehensive learning guide in the form of course. This course covers the fundamentals of blockchain technology and the prevalent technologies and terminologies associated with it. It serves as a foundational resource for anyone looking to dive into blockchain technology. We have designed this fundamental course to be accessible to both developers and technology enthusiasts, ensuring that readers can effortlessly grasp the topics discussed. However, it's important to note that this course is not an exhaustive resource. It serves as a starting point for your journey to explore and expand your knowledge in blockchain technology. Further, you can join Q Academy for more advanced courses on blockchain technologies. Our objective for this course are: to introduce the concept of blockchain and its evolution, to understand the overview of blockchain, public ledger, Bitcoin, smart contracts and block in a blockchain, to understand the structure of a blockchain, including blocks, transactions, and consensus mechanisms, to discuss the role of cryptocurrencies and tokens in the blockchain ecosystem, to analyze real-world applications of blockchain technology across different industries, to highlight the potential benefits and challenges associated with blockchain adoption, to provide insights into the future trends and developments in blockchain technology. Blockchain, despite the inherent block in it, the name has traversed more miles than any other technical term in the recent past. It is echoing in almost all existing IT infrastructures, posing a potential threat to the very existence of the present establishments. The blockchain is said to be the technology of future. Here we are trying to simplify the things for all those who wish to understand the technology. Before going into the details of working principles and other aspects of blockchain, let's look into the genesis of the technology itself. The conceptual framework behind blockchain was first put forward by a group of researchers in 1991. The idea was initially intended for time-stamping digital documents such that backdating them will not be possible thereafter. However, the idea went mostly unused until it was again mentioned by Satoshi Nakamoto in his white paper. Bitcoin, a peer-to-peer electronic cash system. It may be the first time in history that the inventor of a game-changing technology has completely gone anonymous. Satoshi Nakamoto. An anonymous person group is said to be behind the first blockchain, which is Bitcoin. Bitcoin as the first blockchain came into existence, and it was in 2009. In the following years, the Bitcoin became popular, and the underlying technology became even more popular. So the confusion and lack of clarity among people start from the origin itself. A product and its related terminologies went viral before the technology behind it. And when the blockchain displayed its real potential, people were trying to relate it with the Bitcoin terminologies. The result was total misconception and confusion. But it is the other way. Start from blockchain and then try to understand Bitcoin. Why blockchain? It is another question that must be addressed first before going into the details of the technology. To say technology is revolutionary, obviously, it must have a lot of advantage over existing technologies. Here are some advantages of decentralized, distributed, secure and faster, transparent and immutable. The features can be understood well if we look the data structure, data, distribution, data validation, authentication of a piece of data in blockchain, and other related terminologies of blockchain. According to IBM, blockchain is a shared, distributed ledger that facilitates the process of recording transactions and tracking assets in a network. The asset may be a tangible asset like property, house, vehicle, or an intangible asset like digital currency, intellectual property rights, etc. Basically, it stores data and records its movements in a distributed environment. Let's look into its details. It is a distributed database or a public registry that keeps details of assets and its movements, transactions across a P2P network. Each transaction will be secured through cryptography, and later all the transaction history will be grouped and stored as blocks of data. Then the blocks are linked together with cryptography and secured from modification. The whole process will create an unforgeable and immutable record of the transactions that happened across the network. Additionally, these blocks of records are copied to every participating computer in the network, so everyone will have access to it. The great advantage of blockchain is that it can store any kind of asset, its ownership details, history of the ownership and location of assets in the network. Whether it is the digital currency Bitcoin, or any other digital assets like a certificate, personal information, a contract, title of ownership of IP, even the real-world objects. The powerful feature of blockchain is that we can create a shared reality across non-trusting entities. That is, all of these participating nodes in the network do not need to know each other or trust each other because each has the ability to monitor and validate chain for themselves. The irony is that the mutual distrust among participants is the thing which keeps the blockchain secure and verified. Data structure of blockchain. The data in blockchain is stored as individual blocks, that's why it is called blockchain. Just like a linked list, the blockchain is a collection of blocks linked together. So what does the block actually contain? Each block in a blockchain will have the following fields. Data. Stores the data. Previous hash. Stores the hash of the previous block. Hash. Hash value for the current block, which can be used to refer this block. As far as the user is concerned, the data field is the most important thing. The actual data, like transaction details, asset details, etc., are stored in this field. Previous hash will store the hash values of the previous block. Consider it as a link to the previous block. The blocks are connected through this value. We saw that blockchain has its own unique data storage structure, the data. Distribution in a blockchain has also a different approach. They don't follow the widely adopted client-server model, rather the peer-to-peer model. The peer-to-peer data distribution approach gives the reason behind unfettered nature of blockchain. There is no central authority to control. Unlike the client-server model, in P2P network the data is stored in all the participant nodes in the network. All the individual nodes will have the copy of the entire blocks, and a single change in a particular block will be updated in all the nodes. But here is the problem. In client-server model, the data is stored in DB after verification of a central authority. But in P2P network there is no central authority. Then how does the authenticity of data assured? The answer is the validation process and consensus mechanism of the blockchain network. Block validation. As we described above, the asset and its transactions are stored as connected blocks in blockchain. Only the valid transactions are added to the blockchain. Technically saying, blockchain validation is simply the process of finding the block hash. In a blockchain, all the blocks are added to the blockchain after validation only. Whenever a transaction takes place in the blockchain, it will be added to a block. Sometimes one transaction per block and sometimes several transactions per block. It depends on the block size and the nature of the network. When a transaction is added to the block, it must undergo a validation process before it is being added to the blockchain as a valid block. The hash value for the block can be calculated using some algorithms, like SHA-256. The hash value has certain properties too. The main thing is that the hash value should be collision-free, in other words, no two blocks should have the same hash value. Since each block is represented using the hash value, it should be identical. The second property is that the hash values should be irreversible. This means the block data could not be retrievable from the hash value. Now let's understand the concept of blockchain with its overview. Welcome to an overview of blockchain technology. In this exploration, we will journey into the fascinating world of blockchain, a groundbreaking technology with the potential to reshape various industries. So, what is blockchain, and why is it generating so much buzz? Let's dive in. At its core, a blockchain is a distributed and decentralized digital ledger that records transactions across multiple computers. Unlike traditional centralized systems, where a single entity holds all the data and controls it, blockchain operates on a peer-to-peer network, making it transparent and tamper-resistant. Blockchain boasts several key features that set it apart. Security, for one, is paramount. The data in a blockchain is secured through complex cryptographic techniques, making it nearly impossible to alter or hack. It's a ledger with integrity. Here, decentralization is another crucial aspect. Instead of relying on a single authority, multiple participants, or nodes, validate and store transactions. This eliminates the need for intermediaries and fosters trust in a trustless environment. Transparency is a byproduct of this decentralized system. Anyone can view the entire transaction history, ensuring accountability. This transparency has applications in a myriad of industries. But how does it all work? A blockchain is made up of blocks, each containing a group of transactions. These blocks are linked together to form a chain, creating a chronological record. Once a block is added, it's incredibly difficult to change, further enhancing security. Maintaining trust and accuracy in a decentralized network requires consensus. Various mechanisms, such as proof of work, POW, and proof of stake, POS, ensure that all participants agree on the state of the ledger. They validate transactions and prevent double spending. Cryptocurrencies like Bitcoin and Ethereum are among the most famous applications of blockchain. They leverage blockchain to create digital money and smart contracts, which enable automated, self-executing agreements. However, blockchain extends far beyond cryptocurrencies. It's being utilized in supply chain management, healthcare, voting systems, and more. These real-world applications are revolutionizing how we conduct business and secure data. Blockchain isn't without its challenges. Scalability, energy consumption, and regulatory concerns are areas that need to be addressed as the technology matures. Nonetheless, the potential for blockchain to reshape industries and improve trust is undeniable. In this overview, we've scratched the surface of blockchain technology, a transformative force poised to redefine how we interact, transact, and trust in the digital world. As we delve deeper into this remarkable landscape, you'll uncover the myriad possibilities that blockchain has to offer. In the first section, the blockchain and its structure have been discussed. Before we going to explain one of the famous blockchain, our blockchain protocol, the Bitcoin, it would be better having a look into the terms cryptocurrency. The idea of cryptocurrencies has been on the discourse since 1998 itself. The first known attempt for creating a digital cryptocurrency was B-Money and BitGold, but both never came into reality. Cryptocurrencies are the digital or virtual currencies working on the cryptographic principles. As the name indicates, it doesn't have any physical existence or they are not tangible. They merely exist as a set of programming codes, yet provides high security and usability than many existing currencies. Cryptocurrency works on blockchain technology. We have already seen how blockchain works. In the case of cryptocurrency, the ledger keeps the track of cryptocurrency that is generated and transacted across the network. Every individual in a particular blockchain will have a unique account ID address. The cryptocurrency is always associated with this account. Currency is debited and credited to this account. People can manage their account through the application called wallets. Through the wallets, anyone can make the transaction to anyone on the network. Both the sender and receiver must have an account. The transactions are verified by nodes and added to the blockchain ledger. So the immutable and encrypted ledger of blockchain is the backbone of cryptocurrency. For example, suppose initially, my wallet has credited with 100 units of cryptocurrency. From there onwards, every movement of every unit of currency will be recorded in the public ledger. Every participating node in the network can watch the past as well as the present of each unit of currency in the system. Thus, it will be a more transparent monetary system. Other notable features of blockchain are also applicable to cryptocurrency. The encryption mechanism, peer-to-peer network, and no central authority, central server to control. Each cryptocurrency will be working on a blockchain protocol. One of the most famous cryptocurrency is Bitcoin, which relies on the Bitcoin blockchain. And Ether is another fast-growing cryptocurrency which runs on Ethereum protocol. While comparing with the traditional currencies, the cryptocurrencies provide highly anonymous nature for participants. The only visible identity of a user will be his account ID, rest everything will be encrypted. The participants will not have any idea about the real identity of a user. So how someone can use the Bitcoin service? The people are already familiar with the method. It is simple and we don't need any technical knowledge or programming skills to use Bitcoin. The first thing we have to do is create an account in Bitcoin blockchain. For that, the simplest way is to create a digital wallet. There is a number of wallet service providers like Coinbase and Bitcore. While creating an account, the user has to provide a key, similar to a password. Using this key, the wallet will generate a valid Bitcoin private key public key pair. The public key will be visible to all and it is the visible account ID of the user. On the other hand, the user keeps the private key by himself, it is the access key to his account. If a person loses his private key, he loses access to his account and his money. Smart contracts. Smart contracts are lines of code that are stored on a blockchain and automatically execute when predetermined terms and conditions are met. Smart contracts on the blockchain are to streamline the complex process into simple way by removing the middlemen. For this we will store the required details in blockchain, so that everything stored on blockchain are trusted. This will be achieved by smart contracts. Smart contract feature is not available in all blockchains, but it's important feature now because it will provide more capabilities to blockchain applications. Rewards. Miners will get the rewards after successfully mining of each block. For example, in Bitcoin network, miners will get the Bitcoin as the reward for providing stable network. Rewards are cryptographically generated, and based on the protocol rules it will measure issuance and destruction of the rewards. Rewards are required for public permissionless blockchain to ensure the network security. Public ledgers. The public ledger is a record-keeping system that will be used to record the information, and this will be available to all general public. Public ledgers are nothing but anyone can see the transactions storing in public ledgers. No need to take any permission to access the ledgers because these are permissionless ledgers. Here every participant maintain a copy of the ledger. There is no central authority to maintain the ledger records. Participants will do the record verification and validation. Block in a blockchain. A block is a bunch of transactions that have been added to the blockchain. Miners will create the blocks by doing mining. Each block we can treat as page in a ledger book. Each block contains block header and block body. Block header. The block header divided into 6 components. Those are as follows. Version. The block version number nothing but which version of that blockchain it's following, and this field contains 4 bytes of size. Previous block header hash. It is a hash of the previous block's header, and this field contains 32 bytes. Merkle root hash. It is the hash of Merkle tree of all the transactions included in a block, and this field contains 32 bytes of size. Timestamp. This is the block creation time, in the Unix epoch time format. This field contains 4 bytes of size. Difficulty target. This is adjustable difficulty target value set by algorithm, and this field contains 4 bytes of size. Nonce. This is a number that miners change repeatedly in order to produce the hash, and this field contains 4 bytes of size. Block body. The block body contains all the transactions that are conformed with block. Transactions are validated while miner constructing a block. Miner checks that whether he has enough money or not by reading information from blockchain. All the transactions in a block are in a structured format that we call it as Merkle tree. Summary. In present, one of the most emerging technology was blockchain. It has the scope across all the industries from finance to retail and healthcare too. Bitcoin is not a blockchain. The technology used in the Bitcoin is blockchain. Bitcoin is the best example for public blockchain. Smart contracts will be the agreements between the untrusted parties. Once the block is added to blockchain, it's an immutable ledger.